Hi and welcome to this video on KNN Algorithm. I am Raghavendra, an expert in AI, ML and data engineering. By the end of this video, you will be able to explain the working of KNN algorithm, define the distance measure between any two pair of data points, compare eager versus lazy learners, and apply KNN on a sample dataset. KNN is a supervised learning algorithm which classifies data points based on how its neighbors are classified. It stores all available cases and classifies new cases based on a similarity measure. The value of k specifies how many nearest neighbors to include to classify the observation. A data point is classified by majority voting from its k nearest neighbors. Here is a small example where we have two features, that is the chloride level and sulfur dioxide level, and we have the label data about the type of the wine, whether it is a red wine or a white wine. Using these two parameters, we will have to classify a new test observation whether it is red wine or white wine given its chloride level value and sulfur dioxide level value. Let's assume the value of k is equal to 5. For this test observation, we are going to consider the 5 nearest neighbors, and by looking at the class of the nearest observations for using this test data and by using majority voting, we are going to conclude whether this class belongs to a red wine or that of a white wine. Let's try to understand this in more detail. KNN algorithm is based on feature similarity. KNN uses majority voting to decide the class of the test observation. Now suppose we have some objects like squares and triangles, and we have a new object for which we need to identify the type of the object either as a square or as a triangle. Suppose we consider the value of k as 3, and by looking at the 3 nearest neighbors for this new object and by applying majority voting, it is evident that the majority of the data points are square, and we have just one data point which is near being a triangle. So considering that this new object is going to be classified as a square by majority voting. Now instead of k equal to 3, if we assume k equal to 7, we are going to consider 7 nearest observations which are close to this new data point, for which the class is to be decided. In this case, the new object is going to be classified as a triangle by majority voting. In case of binary classifications where we have two classes in the target column, and if the value of k is to be chosen as an even number, the majority voting might result in a clash, and hence k is assumed to be an odd number. K nearest neighbors is based on a distance measure. For a given data point to be classified by a majority or based on the nearest neighbor, the nearest neighbor is going to be calculated based on a distance measure. So Minkowski's distance measure gives a generic formula for the distance measure, which is given by the summation of I is equal to 1 to k xi minus yi raised to the power of q, and the entire thing raised to the power of 1 by q. When q takes a value of 2, it's called as Euclidean distance, where the distance is given by the square root of the summation of I is equal to 1 to k xi minus yi the whole square. If q is equal to 1, then it's called as Manhattan distance, which is given by the summation of I is equal to 1 to k the absolute value of xi minus yi. So KNN algorithms can use either the Euclidean distance or the Manhattan distance in obtaining the nearest neighbors. Every machine learning algorithm uses part of the dataset for training. The model built from the training dataset is used to make predictions on the test data. Let's understand what happens during the training phase. Logistic regression, for example, learns about its parameters during the training phase. Decision tree, on the other hand, builds the rule-based tree during the training phase. Naive-Bayes classifier builds the frequency and the likelihood tables during the training phase. On the contrary, the KNN algorithm does no explicit learning from the training data, but it just memorizes the training dataset instead. When the test data is presented, it uses the memorized training data to classify the data points accordingly. Algorithms like logistic regression and decision trees, which does some explicit computations during the training phase, are called as eager learners, and KNN algorithm, which does no learning during the training phase, is called as lazy learners. Now let's apply KNN algorithm on a sample dataset. So here we have the observations for different data points about the weight and the height, and the target class is the each data point being either underweight or normal. So using these training data set given above, we will have to now predict whether the test observation is either underweight or normal. This is the given test observation for which the class is to be predicted, which has the weight of 57 kgs and height of 170 centimeters. Let's just take a relook at what is Euclidean distance, which we shall be using to calculate the nearest neighbor. Euclidean distance is given by the formula between two data points in the plane with coordinates x, y and a, b is given by the square root of x minus a the whole square plus y minus b the whole square. Now to apply the KNN algorithm, what we do is for each of the training observations, we compute the distance from the test observation. So we have the test observation of weight 57 kgs and height 170 centimeters. We compute the distance from this data point to each of these training observations. First, we calculate the distance between 57 170 to 51 167. We get the distance as 6.7. Then 57 170 with 62 182, we get the distance as 13. 57 170 with 69 176, we get the distance as 13.4 and so on. We calculate each of the distances between the test observation and the training data points. And once we have all the distances, we next find the k closest nearest distances. Let's assume k to be some odd number, that is k is equal to 3, and considering the 3 nearest neighbors, these are the 3 observations which are closest to the test observation which we have. So the data points 58 169, 57 173 and 55 177 are the data points which are closest to the data point 57 170, for which we have to predict the class. Now by considering the class of these 3 nearest neighbors and applying majority voting, we conclude that the class of the test observation to be normal, because if you observe here, all the 3 data points which are very near to the test observation belongs to the class normal. So hence the test observation of 57,170 is going to be classified as normal by looking at its 3 nearest neighbors. Well, we assume the value of k just to be some odd number, but that's not the case which we are going to apply in reality. We are going to choose the best value of k. So how do we decide the best value of k? There are different criteria for doing that. We are going to choose the right value of k which makes the best prediction on the test set. Or in other words, we are going to choose the value of k which results in minimal misclassification on the test data. So here what we do is we are going to run the algorithm in iterations and make predictions on the test set for different values of k. And we are going to pick up the right value of k which results in the least minimal misclassification on the test data set. Another strategy would be to measure the training accuracy itself for different values of k. And the value of k which results in the best training accuracy is chosen to make prediction. So that's how the value of k is decided. So we will have to choose that value of k which is going to give us the best model. Here are the key takeaways in this video. KNN is a supervised learning algorithm which classifies data points based on how its neighbors have been classified. KNN algorithm is a lazy learner which does no explicit learning from the training data, but it just memorizes the training data, does all the computations during the testing phase. Common distance measure used in KNN algorithm is the Euclidean distance. Manhattan distance can as well be used. Choose the right value of k which results in the least misclassification on the test set, or the value of k which results in best accuracy. Thank you for watching this video.